Welcome, everybody, to Connecting the Universe. I'm author and researcher Mike Ricksecker, back at you with another interactive class out of the Secret Library of the Connected Universe. Got a great one coming up for you tonight. We are going to ask the question, does our universe exist inside a black hole? So this is new research that has just come out here, and we are going to go ahead and dive into all of that, of course. And we got to let you know, though, however, before we do, that those that are listening to the podcast version of this later, please want to invite you out every Wednesday night, 8 o'clock p.m. Eastern time, right here, connecteduniverseportal.com. Of course, we also have the live stream there on the YouTube channel and Mike Ricksecker YouTube channel, but through the Connected Universe portal, you get the after show. So I do encourage you to join us out there. And then on Patreon, the after show, the full show with the after show will also be uploaded there. So a couple different options for you. Yeah, connecteduniverseportal.com. Not only do you get this weekly class with the after show as well, but you also get sneak peek behind the scenes video, monthly Q&As, get the Mike's Morning Mug videos, all kinds of behind the scenes footage, plus all of the, oh my gosh, the amazing footage out of Egypt and all of these amazing tours and research projects and things like that we do. So again, connecteduniverseportal.com. And also the Patreon option now has some different tiers in there. So if you want to kind of, I don't know, do it in a la carte sort of style, you can go there. I do have the links down in the description. All right. I also do want to point out that on April 5th, we do have the full Portals to the Stars special event, Merchants and Drovers Tavern Museum, Rahway, New Jersey. Come out and join us for that. That is going to be absolutely amazing. So those that have been attending some of the events I've been at lately, like Conscious Life Expo, Missouri Paracon, it's just in at Atlanta. You guys have been getting a taste of this. Those that are going to be at Lone Star Paracon next week, also going to be getting a taste of this. But the full thing, the full gamut, is a 4-part special presentation. You get Stargates, Portals, Ancient Symbolism. That's one presentation right there. Then you get the Egypt Atlantis connection. That's another. Triangle areas of the world. That's another. Consciousness and time travel. That is another. Plus, of course, we'll have a meet and greet, book signing, and all of that fun stuff there as well. Plus, you're at a historic location. So come on out. Go to my event and tours page, MikeRicksecker.com, and go ahead and click into the Portals to the Stars event there. So really looking forward to meeting a bunch of people there. Great to see you down there, Tom. I'm going to check the chat here real quick. Happy rainy evening. Must be raining in Chicago there. Scarlett, great to see you as well. Kurt, good to see you too. So, all right. So let's go ahead and start getting into this. Yeah, black hole universe. Are we living in a black hole? This was kind of a interesting proposal here from, well, really it came out of research that was done with the James Webb telescope. And so James Webb telescope, now this was launched a couple years ago. Here's that guy right there. And its mission was really to observe parts of space and time never seen before, gazing into the far reaches of the galaxy where you have those first stars and galaxies that were born over 13.5 billion years ago, which, although there is a study that came out here just recently that has postulated we could be as many as 27 billion years old. So essentially, maybe some math was wrong there, and we're supposed to be double the age. Yeah, who knows? Maybe we are. None of us were around back then to say, oh yeah, here's the beginning of the universe. Actually, I will say this, our consciousness was. Our consciousness was around. So it's kind of like a matter of maybe remembering. But, as far as the, 3D human body, yeah, we went around back then. But that James Webb telescope is going out there and trying to, discover these different aspects of our galaxy that, or not our galaxy, our universe, that we haven't yet been able to detect. So, yeah, just the other day here's a nice shot of a black hole here. There was a uh, report that came out in which, yeah, they were saying that the data that they've been getting off of the James Webb telescope is indicative of a possibility that we may actually be living inside a black hole, which is really pretty wild to think about because we have black holes within our universe. In fact, the center of our Milky Way galaxy is a black hole. We are uh, basically orbiting it the way that our sun or our planet orbits the sun, so too our galaxy orbits a black hole. But now they're saying we may actually be inside one as well. So we're going to get into some different aspects of this tonight about what's beyond the universe, and almost might even be like that whole Russian doll thing that inside a black hole, inside a black hole, inside a black hole thing. So here's what the scientists had to say about it. So this is Leor Shamir of Kansas State University. And basically, he said that our explanation is that the universe was born rotating. That explanation agrees with theories such as black hole cosmology, which postulates that the entire universe is the interior of a black hole. It was initially inspired by the good match between the radius of the universe and the radius of a black hole, the Schwarzschild radius. It also explains the accelerated expansion of the universe without the need to assume dark energy, which is pretty interesting to note because you've heard a lot of theories about dark energy, dark matter, all of these things, which we actually can't prove. We don't, and I mean that we are able to kind of theorize it through math, but to actually say, hey, hey, there it is. There's the dark matter. There's the dark energy. I mean, we don't have that. It's basically the inverse of everything else. So like all the space around us, like I'm matter, my microphone is matter, my computer is matter, all of that, but all the space here would essentially be dark matter. And theoretical physicists have had challenges with this because other than through some fancy math, they haven't actually been able to show that it exists. It's all basically in theory right now. So this idea now of us being in a black hole makes all that a little bit easier without having to prove that dark matter or dark energy actually exists. Yeah, I know. Start wrapping your head around that. Hey, Jack McCarthy's in the house. My buddy there from TA when I used to work there. Great to see Michelle Brandenburg in the house as well. Fantastic. And Sarah Youssef is in the house as well. Been a little while, Sarah. Great to see you down there. So, all right. Now, I will say this idea of us actually living inside a black hole is not exactly a new idea. Okay. This is an idea that has been postulated before. Once it was started to become more accepted that black holes actually existed. Now, in today's day and age, we're like, oh yeah, sure, black holes, of course. Well, that wasn't always the case. Guys like Stephen Hawking had to like work their butts off to prove that, yeah, black holes are a real thing. They do exist. And there was a point in time where just showing that there were other galaxies out there was a challenge. So, this is something that has taken time to actually mature to the point where, not only are we accepting that black holes are real, that at the center of our Milky Way galaxy is a black hole, and now this idea that we may actually be inside one. It's taken a little while to get here. So when these ideas of a black hole were first starting to get a little bit more popular, we weren't really so sure what they looked like. Okay, we've seen some fuzzy images now, and they just look like a blur when you actually see real photos of black holes. And I should have loaded one up. But we do have this great image here from the film Interstellar, and this is kind of it's a good idea of what it would actually look like if you approached one. But that's all computer graphics. we have some real splotchy images of ones right now. Well, 45, 50 years ago, when we were theorizing this, we didn't even have that. It was just some little, movement in the sky. Hey, where'd the light go? And then we applied some math and came up with the idea of the black hole. So then the question was, okay, if it's, sucking in, all matter, including light, what does that actually look like? So, and if it did, what was beyond? So you had, we're going to use an example here I've never used before for, in any of the Connecting the Universe classes, or when we were beyond the shadows, or even back inside the Upside Down. Does anybody remember the film The Black Hole, which was came out in 1979? It was actually a Disney film, and it was the first Disney film that was PG rated. Everything else before that was G rated, but this was actually their first PG film. And so their idea, the way that they showed it, was actually more like a wormhole. And in fact, at one point in the film, when they actually go into the black hole, they actually show the whole wormhole effect. But for those that might actually remember, kind of the iconic scene from that is the giant ball of fire, the meteor, kind of rolling through that kind of main corridor, and they're on the bridge. It's actually a pretty cool shot. But yeah, this this film had some, the iconic Maximilian robot in that, and you had these kind of really early depictions of, you can see here, it looks like a spinning galaxy that they're looking at outside the window there. So that was some early ideas of what a black hole would look like. Now we know it would be more of like a giant ball, giant sphere. And so that is, again, what, they've done there in Interstellar. But yeah, an early depiction of this was more of the opening of a wormhole that was sucking in all matter and light and everything else. And, the question then became, okay, if that's what it is, where does it go? What's on the other side of a black hole? What's in now? For us, it would be what's inside the black hole. What's in the middle of it? And now we're thinking universes. So do we have many tiny universes within our own universe? It's an interesting concept to think of. So in this particular film, what's interesting, when they finally do, go into that black hole, again, this is a Disney film, and it gets like really trippy, and then it gets really dark. Like we're talking like, the melding of man and machine and fire and brimstone and just, all kinds of crazy stuff is going on. And then it gets trippy again. It's it's almost like they went down the road a bit of 2001: A Space Odyssey, and they threw in some dark stuff, and this was Disney. And then they come out finally through the survivors using the probe through what essentially is a wormhole. They come out on the other side, and it seems like they're in another galaxy. We don't know, because there's no dialogue for like the last almost 10 minutes of the movie. They're just going through all this trippy stuff. And then, like I said, there was the dark stuff too. However, if you were at my age, in 1979, I was 4 years old, and I probably got this when I was maybe 5. I had the Disney storybook that you would play on the record, and I still have it to this day, obviously. But there is an ending, a different scene in the storybook, and I will actually read that. So it's at the very last, and they use a still from the film, but here it's a different, little bit of a different conclusion. So suddenly everything was calm. Now that part is true. They'd come through safely. Before them stretched a giant universe filled with planets and stars that had been swallowed by the black hole. So take note of that. A giant universe, okay, had been swallowed by the black hole. Kate was stunned. What will we do now? Again, in the film, there's no dialogue. Kate was stunned. What will we do now? Well, we can't go back, replied the captain, but that's no reason to give up hope. We've been trained to find new worlds. Let's go find one for ourselves. So, right there, you have this idea that within the black hole was a whole other universe that they had traveled, through that wormhole to another universe entirely. So you already kind of have those seeds of the idea right there. And back then, they probably had no idea. Well, we know they had no idea of what it was that was beyond. And 45 years later, geez, we're really dating ourselves here. 45, 46 years. We are now we actually have science coming forth and telling us that, yeah, actually, these black holes may have universes inside of them, and we may actually be inside one ourselves. So, yeah, Tom remembers it. Saw the movie in Ohio. That is fantastic. Although it's graphically impressive, but the story was okay. The story was okay. It's funny. My father's first computer that I built him in, was it 96? He called it Maximilian, which was the giant robot. Yeah. Let's see. Just trying to check your comments here. Okay. Yeah, a bit Voyager-esque. Absolutely. We'll get to some of these different interconnections of the universe. So if we have these black holes that are actually universes, I've mentioned the book before, Parallel Worlds by Michio Kaku. And it's a really, really fascinating book because it does get into the theoretical physics behind multiple universes, but not in that whole sense of like with the Marvel movie universe. I mean, he does touch on that a little bit, but it's more of the it's physical universes, and not this idea that we're splitting off into all different, like 5 billion different timelines or whatever. That's just science fiction and storytelling for the Marvel universe. But this idea that there are actually physical universes out there that they're kind of likened to being bubble universes. And I actually left the book over there, and there was something I wanted to read to you guys out of it. But essentially what happens here, I'll get back to it because there's a video clip that I'm going to play here in a little while, and I'll come back around to it. So with these universes, when they are created, there's almost like a Goldilocks zone that occurs with them. So like with our solar system, it's really, you have to take what's going on here and replicate it and scale it up. Okay. So within our solar system, we have our sun, we have our planets. Our planet sits in this nice, what we call the Goldilocks zone, and we were able to develop life. Not all solar systems are like that. We don't know how many are like that. We're trying to find them. We do a lot of research on exoplanets, planets that are outside of our system, to try to learn more about them. And we do believe that there are ones that are sitting in that Goldilocks zone that have the potential to have life, but others don't. So you scale that up to galaxies. You're going to have galaxies that are in that Goldilocks zone. You're going to have, they're going to have solar systems that have life teeming within them. They're in a good spot. Same thing, scale it up to universes. You're going to have some universes that are essentially in that Goldilocks zone. They were able to develop systems that have galaxies and systems that have life within them. And other ones are going to essentially fizzle out. So, if you take a look, just this depiction right here, you see all these different like bubble universes here. So each one of these is going to have a different nuclear force, a weaker nuclear force might prevent the formation of stars within those universes. So if you don't have the formation of stars within that universe, then it's not going to go anywhere. Nothing's going to happen. If you have stronger nuclear forces within those universes, then stars could burn out really quick and not actually have time to form life. Our universe happened to have been one of those that we ended up with the right amount of nuclear forces to be able to develop stars, which from there were able to develop life. So see how that kind of scales up like that? So that still works in the sense if we are talking about we're living in a black hole. So rather than, I mean, this is very beautiful, very graphical. You have these nice bubbles with the stars in them and all that. But it really could just be, these giant black holes that are all near each other. Then the question becomes, what is beyond that, right? What's beyond those black holes? That we don't know. Is it really an even bigger, more expansive universe beyond our universe? If we think about, our center of our galaxy, the Milky Way, is a black hole. Is there, another like smaller universe inside that has, other galaxies and life and solar system, things like that teeming within it? We don't know because we can't see beyond the singularity. We can't see beyond, or we can't see the singularity. We can't see beyond the event horizon because it's so powerful. It is, sucking in that light. So that's a dilemma that we won't be able to answer right now. It's something that we're going to keep speculating on for a while until we develop some other technology to bring us to more information. That's been the fascinating thing about the James Webb telescope right now is that we didn't have this information before. We had Hubble, we had Chandra. In the Chandra X-ray telescope, I've shown this image many times. The Chandra X-ray telescope has been fascinating because this is basically looking at the background radiation of the universe and showing that these are galaxies. All those little yellow and orange dots that are on there, those are all galaxies. You can see they're all glowing. Well, what's all that webby stuff? Well, that webby stuff, those are gaseous filaments that are actually connecting all of the universes together. So that's why we call this the connected universe. Well, again, let's scale that up. If this is true of our universe, all those galaxies are connected. We know within our solar system, all the planets are connected. Each planet has an effect on the other. If you were to delete one of the planets, then that would have an effect on as far as their the pull on gravity from the sun and all. There's a distinct relationship. If you got rid of Jupiter, a lot of those asteroids and comets and things like that coming into the solar system would smash into the interior planets a lot more often because Jupiter actually, with its gravitational pull, takes a lot of those in. So, we all have a symbiotic relationship within our solar system. Same thing with our solar system to the other solar systems within the galaxy. Same thing with the galaxy to the other galaxies within the universe, which also, take that up a notch. Something, whatever that is out there, the universes are having a symbiotic relationship within whatever it is that is out there. So this is a kind of rudimentary, I grabbed this off the internet, basically showing two universes that are connected to each other. I know it's got a little knot down there. We're going to talk some more about this here in a little while. This is the idea that we can actually connect the universes possibly with a wormhole. But I would also surmise that we're going to have this sort of relationship with the kind of the Webby effect with the other universes as well. So we all have this, call it the connected universe. We all have this relationship with each other. And Tom, how'd you know we were going to go there? Maybe a black hole is time portal that brings us back to our universe and we start at our beginning again. So we are going to talk about that. And Sarah, looks like a neural map. It pretty much does. It pretty much does. And Jeff is saying Euclid just found 26 million galaxies. Pretty awesome. Yeah, it's interesting when they've been publishing all of this material from, especially from James Webb here, the James Webb Telescope. You keep having these scientists say there's a lot more out there than we previously thought there was. Like it's like they did measurements of what we saw through Hubble and other telescopes that we have, and just multiplied it or something, and deduced, oh yeah, well we should have approximately this many, this many galaxies out there. And then they start doing this research with the newer technology, and they're like, oh, there's a lot more out there than we previously thought, and it goes deeper. And that's why they're kind of changing things up. Like, yes, the approximation of the number of galaxies, the approximation of how old the universe is. Now they're not all. This is kind of mixed right now, but the idea that the universe may be as old as 27 billion years old rather than 13 and a half. And like I said, I think it sounds like they just doubled it, but they are showing that there's so much more out there than we previously conceived. So Tom kind of jumped on our next topic here. With black holes, and we've talked about it in the past as far as when we're talking about real-time travel, because black holes bend space and time. So one of the ideas that's been put out there by Ronald Mallet, he's a scientist, and he's been trying to figure out a scientific way that we can go back in time. And he has a very personal reason for that, which I completely respect. And those that have been following me here know that I believe real-time travel has more to do with consciousness and meditation rather than getting into a DeLorean with a flux capacitor and zooming off. Well, this other idea is that, well, if you decided to slingshot yourself around a black hole, then because black hole bends space and time, you could conceivably take yourself all the way back to the time at which the black hole was created. And then you'd have to somehow ferry yourself back to Earth. So, that's a challenge of it, is, getting out there to begin with, somehow surviving that process, and then coming back here. So I have a video clip. I did a Mike's Morning Mug about this time last year, and I actually made this one public. It's on the Connected Universe portal, and usually my Mike's Morning Mug videos just stay on the portal, and now again on Patreon, since we've reinstituted that. But sometimes I'll publish a clip out on social media. This time I decided to post the entire video out on YouTube. So I'll provide that link in the description. I think I forgot to add that in the description this time, but I will do that after the show. This is like a couple minute just snippet out of that longer. It's almost like a 20-minute video. So it's actually me reading an excerpt out of Travels Through Time, but this is where I kind of go through and explain what I'm talking about here. And I deal with it right at the very beginning of chapter 11, or I call them cycles in this book. Chapter 11 on real-time travel and what real-time travel looks like. So I published this book last year, August 2023. Our theoretical physics show us that the gravity of black holes is so strong that not only can light not escape it, but its gravitation field also bends space and time. As space stretches, so does time. Thus, a clock that is held near a massive object will tick slower than one held near an object that is much less massive. We briefly talked about time dilations back in chapter 2.
In comparison to a clock here on Earth, a clock near a black hole will tick much more slowly. So if you could get close enough to the center of a black hole without crossing over the event horizon, at which point there is no escape, and return back to Earth, you will discover that time on the planet has passed quicker, and you will have traveled into the future upon your arrival. Physicists also believe that black holes can bend time so much that it can wrap back on itself, creating a loop that can take one back into the past, at least to the point at which the black hole was created. And see, this is where we get into his idea of building a machine, and you can only go back into the past to the point of when the machine was built, but this is a principle using the black hole. In other words, if you found a black hole that was created at the time of the Old Kingdom ancient Egyptians, then you could take its loop as far back as that. But if you wanted to travel back to the time of the dinosaurs with that particular black hole, you'd be out of luck. Of course, there are some logistical problems to all of this. First of all, the closest black holes to Earth, Gaia BH1 and Gaia BH2, are 1,560 light years and 3,800 light years away from us, respectively. We're not getting near those anytime soon. Secondly, in order to get that close to a black hole and be able to successfully navigate away from it, you would have to be traveling near the speed of light, and faster than the speed of light if you accidentally slip past the event horizon, in order to get away from it. Finally, the gravity of the black hole is so strong that you and your craft would likely have been stretched out in a grueling phenomenon called spaghettification, stretching you out flat like pasta and, essentially, destroying the craft and killing you. So the idea of using a black hole as a natural time machine really is not feasible.
Yeah. So pretty much, I agree with myself there. It's really not feasible. Just the amount of time it would take us to get to the black hole. I mean, yeah, think about this. It's taken 50 years for the Voyager crafts to get beyond the solar system. I think when they were officially beyond the heliopause, it was something like 40 years. And now at 50 years, they're starting to shut down. Not to mention if you had a human in there, 50 years. I mean, if you're going to send a 20-year-old up there, or maybe a 25-year-old, they would be like 70 or 75 right now. Would they still be alive? Would there be enough resources there, like food and oxygen and all that, to get a human just to that, let alone out, thousands of light years away? So, Tom, that answered your question. It was, as far as how far the closest black hole was. So yeah, we can't physically do it right now, which is why we do need to look into some of this technology and figure out, how we can traverse the cosmos. At some point in time, the sun will become a red giant and engulf the Earth, and we'll all be, Earth will be gone. So if we want the human race to survive, we do need to do something to get beyond our solar system and develop interstellar travel. So, but yeah, so that's for me, for time travel, that's not feasible. It's, while theoretically possible if you survive the slingshot and don't get spaghettified. Yeah. So, and Michelle, truly believe consciousness is a tool to travel anywhere, anytime, and explore. Yeah, and I dive deep into that in Travels Through Time, how dreams, premonitions, ESP, these aspects are certainly a form of time travel. People experience time slips and things like this, deja vu, and all of that. So it's a deeper topic for another time, which we're not really going to dive into here with this particular class. But I did, while that was playing, grab Michio's Parallel Worlds. And actually, my bookmark here, if you notice, this is Boba Fett as a Bigfoot, as a Sasquatch. That's a design by my friend Aaron Sager. So thank you, Aaron, for that. I will not continue, if Aaron's watching this at all, will not continue to use that as a bookmark. But it was right there, and I put it in there. So, and it actually gets specifically into this idea of of universes and black holes. This is actually in a section called Evolution of Universes, which is following up from the whole multiverse aspect. So he says, if universes can sprout from black holes, as some physicists believe, then the universes that dominate the multiverse are those that have the most black holes. This means that, as in the animal kingdom, the universes that give rise to the most children eventually dominate to spread their genetic information, the physical constants of nature. If true, then our universe might have had an infinite number of ancestor universes in the past. And our universe is a byproduct of trillions of years of natural selection. In other words, our universe is the byproduct of survival of the fittest, meaning it is the child of universes with the maximum number of black holes. So kind of a interesting concept there that, the whole survival of the fittest of, it makes sense that it would be applicable to, not just us. I mean, like you're saying, we see in the animal kingdom, you know, uh, animals go extinct, these sorts of things, because, these other animals, survived and those couldn't. And, maybe they were the prey of those animals and, food source ran out, or, whatever it was. Or there was a mass extinction event, like the dinosaurs, blew out, but, other life forms survived. And, could very well, and so what's left to, keep things going and recreate. So the same thing would be true, because again, everything is connected, of universes as well. So, kind of going back to that, development of universe. Now we don't know what's creating those. What does create these universes out there? And I've long talked about the, we have that ancient symbolism of the Ouroboros, the recycling and renewal of not just us. I mean, they use that on their iconography on, like on the tomb of, or the shrine of, the burial shrine of King Tut. You see it within other tombs as well out there. But they also used it for other iconography. So yes, for the person, but they also used it for the earth. They also used it for the universe, the constant recycling and renewal again and again. What was before the universe? The universe. What was after the universe? The universe. Again, scale it up. So we know that this solar system was born out of another. Our sun does not have enough, it doesn't have enough power to actually create a solar system. There was something else that was before us. There was, a bigger star or something. We don't really know for sure, that had originated, went supernova, and from that, all of the gases and dust and everything reformed to create what we have now. So, this is why, that that saying, we're all made of stardust, is true. We are absolutely all made of stardust. And that genetic coding from our previous solar system is within here. And this is the way it formed up. Now, that previous solar system probably did not look exactly the way that this one did. Probably looked very differently. We don't know what type of life forms are on there, but the genetic encoding for life was within there. Now, and that could have, I have a lot of different theories as far as where humanity came from, elsewhere in the universe and this sort of thing. But, we can just kind of take those basics and say maybe the animal life and plant life and all that's, reformed here. So you can say the same thing for, again, things that are bigger. You could say the same thing for universes when, let's take the galaxy first. When the galaxy, dies, the what's left, the gases, the heat, the dust, all that will reform and create something else. And this will go on exponentially until, finally things eventually fizzle out. And then the universe itself, the same thing will happen. The universe eventually will end, and then it will reform. So that's why I keep saying, what was before the universe? The universe. What was after the universe? The universe. And the ancients knew this. It was in their symbolism. How they knew it, we don't know. It was the aliens, right? The aliens told them. And yeah. So, and thanks, Kurt. I'm glad you appreciate the morning mugs. Yeah. Jack asking, are you familiar with Max Tegmark's writings on parallel universes? Sound like you were discussing them earlier. I haven't gotten into his specific work. Yeah, we were talking about parallel universes a bit earlier. When we're talking about, there are basically in our theoretical physics show this, that we have, there are multiple universes that are out there. I'm not going to get into that again. Rewind. So, but yeah, I was talking about that a bit earlier, Jack. So, talked before about if we have these wormholes, and I showed this earlier, the connection of multiple universes. Now, this was the connection of multiple galaxies, which then we could say when we go further up the scale to universes, then we can connect those universes. We can connect them via wormholes. And again, I'll give Michio another shout out. He actually talked specifically about connecting universes with wormholes there. That when we talk about the Einstein-Rosen bridge, that in order to do this, you have to bend space and time. We don't know specifically how you bend space and time, but if you were to bend space and time, take 2 points out in the universe, you want to join them because they're too distant. You want to be able to travel it. You fold over space and time, and you connect them with this bridge. Theory of relativity actually shows that you can do this. So and you create this hole. And in fact, when we were talking about the black hole film earlier, that's essentially what they were showing here. Was they had that funnel into the tunnel, nice, and connected them. Now, we've talked many times that that circle opening, circles 2-dimensional 3D space, it's going to be a sphere. And so our portals, our wormholes, our stargates are generally going to be that what we call a spherical hole. And you would pass through into that. So again, you have this idea of sphere, which is the actual shape of a black hole. It is actually a sphere. So when 2.5 years ago now, when they were trying to create a wormhole in a lab, and they successfully did this. It was on the quantum level. It was Fermilab. And they did this at the quantum level. The way that they did it was they created 2 tiny black holes on the quantum level, and they connected them with a wormhole. And they, made it big and public. We've created a wormhole in the lab. Now, what's interesting to me is they created 2 black holes in the lab too. So to me, that one's that makes me a little bit nervous. Like, okay, I realize it was on the quantum level, but if you make that too big, are you going to suck the entire planet into your lab? That part kind of spooks me a little bit. But they created these 2 tiny black holes in the lab and connected them with a wormhole, and they sent a message through. And the big joke about it was that the reporters were asking them if they could send a dog through, and the scientists are kind of throwing up their arms. Are you kidding me? Yeah. For one, it's small, quantum level. No, but why would we send a life form through first? You would do something like send a probe. Keep that idea of the probe in mind. So this actually makes a whole lot of sense if we're talking about connecting things like universes together. If universes are actually themselves black holes with everything else inside of them, then if we are in the lab connecting two black holes with a wormhole, then it makes sense that you could, two gigantic, huge universes that are black holes could be connected together, with a wormhole, with a portal, with that tunnel. We could do it. And so when we are experiencing something like UFOs, we're experiencing extraterrestrials, we're experiencing an interdimensional being. There's a lot of ideas here. I'll throw this one up on the screen again. Sasquatch. A lot of people believe that, maybe Sasquatch are interdimensional beings. Are we talking about maybe not necessarily visitors from another planet? Another planet in our galaxy. Okay. What about another planet in a different galaxy? Okay, we've talked about that too. What about a different planet that's in a different galaxy that's in a whole other universe? If we can connect the universes, those black holes, with a wormhole, like we are doing in the lab today, then it could stand to reason that these beings that we are experiencing are not just from this universe, but could be from a whole other universe altogether. And I don't mean some multiverse thing where because I made a decision, it created a whole other timeline sort of. No, I'm talking about a completely different physical universe, one of these other kind of quote unquote bubble universes that are out there connected through a wormhole. Very well could be. We've had a lot of reports here. I mentioned, okay, we're going to talk about the balls of light. So when we had all of that, and we see balls of light in the sky all the time, just look up for a while, you will see them. But when we had all of that drone activity going on, people started looking up, hey, what's going on with the drones? And they started seeing all this stuff in the sky. And they started seeing like the drones coming out of these orbs, these giant balls of light in the sky. Now, we covered that a couple of months ago, and there could be a lot of different explanations for what these are. Yes, government testing, sure. I think a lot of them were. But when you're having some of these come out of the balls of light, again, if we keep in mind, send a probe through, right? From on the quantum level, black hole to black hole, they're sending a message, and hey, we're not going to send a life form through first. We would send a probe through first. Well, what if these things coming out of these balls of light is somebody out there sending a probe through first? And hey, if you're going to send a probe through and you actually, maybe a little bit of something about where you're sending it to, you're probably going to want to mask it so it kind of blends in. So why wouldn't some other ET or life form out there, they're trying to check out, hey, what's going on with this planet that we were able to access, whether it's from our universe or another one. You would probably want to try to blend in. So yeah, it makes a lot of sense. So these balls of light could be the access points for ETs to come in and out of our universe, our world. Could even be other points in time, could be connections to other dimensions. Yes, all of that is on the table. But now we have science that's throwing this idea out on the table, and they have talked about it before. Again, it's not a completely original idea. We're just now getting the science to back up the idea that these could be other universes here that we are connecting to. Absolutely. I do have a note here on, because we could even get a bit deeper into this if we started talking about the simulated universe. And we got like 10 minutes left in the show, and I know that there are some comments down there in the chat. What would this be if we take this to the idea of the simulated universe? Well, I mean, this would still be all inherent within, if we use the idea of a computer simulation. And again, I I believe we're in a simulated universe, but I don't believe it's a computer simulation. I believe it's something more organic or biological in nature. But to some degree, a simulation. And again, our ancient world religions talk about simulation, even though they don't use that word. They use, words like reincarnation and things like that. It's the same concept. So yeah, the idea that we are in a simulation, these would all be, aspects of that. Absolutely. So, all right. What is it? Okay, so yeah, Jack is saying tag mark breaks them into 4 distinct types, quantum mini worlds being of so yeah, and you know what? The name probably doesn't ring a bell, but I know but I know Michio does cover that in this. It's been a while since I've actually read through this, probably a couple of years. But he does talk about those distinctive types like that. So yeah, just didn't recognize the name tag mark. What is this, Sarah? Probing orbs imitating dust bunnies? Sure. Are you saying that this looks like a dust bunny? I mean, that was a massive giant light in the sky outside Edinburgh, Scotland. You haven't been around a little while, Sarah. You've missed a few things. I've actually shown this image quite a few times. That was during the when all the stuff was going on with the drones. And what was fascinating about that was, we had the drones going on all over the world, but there in Edinburgh, it wasn't really so much the drones as it was these lights in the sky that were like all over the place. And I had like multiple people reaching out to me. So I was like getting, 2 different sides of the image. So that was one that was, it was over the water there, further forth. This was looking from the north, and I have another image that was actually looking from the south at the exact same that was taken on December 20th. So yeah, it's some fascinating stuff that was going on. Yeah. So all right, guys, I think we are going to go ahead and wrap this up and get ourselves into the after show. So do want to encourage everybody. I'm gonna throw it up here again for those that may have missed earlier on. Portals to the Stars event that is April 5th at Merchants and Drovers Tavern Museum, Rahway, New Jersey. So you can get the information from that on my website, MikeRicksecker.com. Go to the Events and Tours tab. And that's a 4-part presentation. We got the meet and greet. We got the book signing, Stargates, Portals, Ancient Symbolism, the Egypt-Atlantis Connection, Triangle Areas of the World, Consciousness, and Time Travel. And of course, also join us for our 3rd annual Stargates of Ancient Egypt tour this November 11th through 23rd. Yes, you Americans, you will be back in time for Thanksgiving. But we get people from all over the world on that tour anyway. Last year we had people from Switzerland, Scotland, Costa Rica. It's really an amazing time. So definitely encourage people to join us. So, all right, everybody, that will do it for this evening. Those that are members of the portals, please stick with us, hang out for a little bit longer. And for everybody else, till next time, time really exists.